Salve, sono Mark Waite. Voglio parlare di l'evoluzione di containers in integrazione continua. I slide sono in inglese, io sono americano. Allora, allora parliamo con voi di hardware e software e l'evoluzione di hardware e software nella integrazione continua. Sono io, mantengo il plugin Git per Jenkins. L'ho fatto per 4 anni. Parlo inglese da lingua prima. Se non mi capite, per favore si alzano la mano e parlerò in inglese. Allora? Okay, I will speak in English if you would like. È migliore a voi inglese o italiano? Inglese? Oh, allora. Very good then. I'll just speak in English. Is that okay? All right, great. I practiced really hard my Italian, but I'm... Ho fatto 2 anni in Italia, 35 anni fa, allora non ho parlato a 35 anni e si sente. So I'm part of CloudBees. CloudBees is the company that maintains Jenkins and contributes to the open source project. I've been through a bunch of different changes in software development over several years. I've worked for large companies and small companies. I've done waterfall, I've done Scrum, I've done extreme programming. Yes, I've made lots of mistakes. And this is about many of those mistakes, all right? The Jenkins Git plugin is installed in 180,000 installations worldwide. Average usage is probably 10 users per installation, some much larger, some smaller. So think 1.8 million to 2 million people regret it if I make a mistake. All right, so bad plugin releases are really, really bad. All right, I like Git a lot. So in software development, there are lots of challenges. Challenges are just the nature of what we deal with, right? One of my challenges is that creating software is hard work because I have to support multiple platforms, multiple operating systems. In my case, Alpine, CentOS, Debian, SUSE, Red Hat, and Ubuntu, just in the Linux variants, and there are important and critical differences between CentOS 5, CentOS 6, and CentOS 7. All right, so you understand one of the problems that I see when I deal with this kind of thing is that platforms are hard. And then there's this other little system here, Windows, with its locking file system that has a very different behavior than any other platform in this pool. So software development is hard, in part because we get variation in operating systems. Software development is also hard because sometimes the things on which we depend change. In my case, weekly releases of Jenkins. Very little testing. If it passes the unit test, it's shipped. Long-term support releases every quarter. Much more testing and many more people who care very deeply if things are broken. Git releases every quarter. The JGit project, the Java implementation of Git, releases even more frequently than that. Lots of things that are moving underneath the code that I am delivering. So software is hard work also because in addition to those other things, there are multiple use cases happening, and many of those use cases are cases that I did not know existed until the user told me so by saying it's broken. In my case, there could be local or distributed use where you may have developers sitting in Italy and in Switzerland and in India and in the United States, or you may all be co-located right inside the same walls. Branching models, so many different branching models, it makes your eyes bug out, right? It just astonishes us how we authenticate. Shall we use HTTPS? Shall we use SSH? Shall we use Kerberos? Shall we use something else? All of them create challenges. Now, how do we meet those challenges? Now, by the way, Part of this talk is I'm telling my story, and I hope that you will hear and reflect on how these things might apply in your experience. Because my experience is actually irrelevant. Truthfully, it doesn't matter. But what matters is if you see patterns of what I've done, you may make fewer mistakes than I've made as you go forward to your next improvement. So the challenges. One of the key ways to meet these challenges is to use continuous integration. All right? Test more often, deploy more often, experiment more often, fail more often. Good, good. We've learned this. Now, here's where my evolution started. I started by developing on a desktop machine. And I compiled on the desktop machine. It's fast, it's easy to configure, it just works. All my tests run, I commit, and I release software to production, and I'm done. Except nobody else can do it that way. It's hard to scale to other things. If my desktop dies, things are very bad. And I have this little snowflake, one thing. So that was my hardware side, desktop deployment. My software side, build scripts were local, easy to use, absolutely. I knew exactly how they worked, and no one else did. It's really good, except it is certainly not the best way to do things, because all it uses is the knowledge that I have on how to create it. So we got better, though. After desktop deployment, I put up a continuous integration pipeline, in my case using Jenkins freestyle jobs. I put this job up, and all of a sudden it was telling me when things were failing and when they weren't. And you'll see here, this is my basement, and I learned the word for basement and have now forgotten it. Piano interrato? In my basement is this set of equipment, and it's crucial to doing what I do. If I don't know that the Red Hat box here, or the CentOS box here, the Windows box here, and the Debian box here are all successfully running, I should not release. Okay, that's good. So this was easy to configure, and because all this equipment is old and donated, it was low cost. My power bill is not so low cost, but however, it's still really not portable. Nobody else has this environment. It's just my basement. It's underutilized because inevitably I'm not using all the equipment that's there. Some of it is just sitting, wasting power. It is a single point of failure. If I lose power to my basement, things stop. All right, in my software evolution, a single job worked pretty well. It was easy to create, easy to use, repeatable, but it didn't do anything more complex than a single job. And as an example, it didn't test Windows. It didn't test, is CentOS 5 still working? What about Debian 9? So lots of things it just did not do. So I started standardizing, and this let me construct machines repeatably, even if in this hardware special case. Remember the definition of the machine, use that definition to create new copies of it. However, still over-provisioned and still a single point of failure. Now, the improvements continued. I started using multiple jobs. Remember, I started with no jobs, one job, and now we've got several different jobs that are all, and I can chain them together. And you know what I get when I chain them together? I get a brittle chunk of code that is really hard to maintain. But it worked. So brittleness, but it got more complex and more capable. Then magic happened for me. Docker released containers. And all of a sudden, I had the ability to standardize all sorts of definitions about my infrastructure. I could define that a system looks exactly like this, and it could look like CentOS 5, CentOS 6, CentOS 7, Debian 8, Alpine Linux. I could standardize all those things and express them in source code, and it's much, much better. And I can also spin them up and tear them down very rapidly. This phase was where my testing efforts became dramatically easier. All of a sudden, I could test code and have very complex environments in seconds. On the flip side, On the software side, I switched to using Jenkins pipeline. So this was now, instead of expressing how things are constructed as a series of bolted together jobs, there's one piece of code that says what it is. It was much easier now and much better. Now things get even better as we evolve from this. Next step is use somebody else to orchestrate the deployment of those containers. Use somebody else to tear them down so that I don't have to think about how deployment setup and teardown happens. Kubernetes has been absolutely wonderful at handling infrastructure for me. Now, on the software side, pipeline shared libraries have given me best practices. You notice that I created pipelines myself, and I ended up with an arm's length of code in my pipeline definition. It was as good as I could write. Well, in this evolution, I have one line of code in the plugin that builds it. It says, build plugin, several parameters, and that's it. Now, where did the rest of the code go? Somebody else wrote it for me. Somebody who really knows this stuff. And that person who wrote it used the best skills they have, which are far better than my skills. And I have now a much better build system and much less code to maintain. That set of changes have been breathtaking for me in terms of getting where we are today with how easy it is to do continuous integration compared to how it was only a few years ago. Now, why Kubernetes? Because it runs everywhere. And it runs on everybody's equipment, either in the cloud or on-premise. It does all sorts of work for me that I don't have to do anymore. I have gotten a much better life about development because I can let somebody else do orchestration. Question and answer. I think we're at past 5 p.m., so now's a good time. What questions do you have?